In this video, we are going to see how to find the domain of a function. So if you want to recall what is the domain of a function, domain of a function is nothing but the largest set of real numbers for which f of x is a real number. So basically, the largest set of input for which the output is a real number. That is what the domain is. So when you're trying to find the domain, you will always assume that all numbers can be input into the function. So that is your starting value. So for example, if the function given to you is f of x is equal to x squared minus 5, this is a polynomial function. So for this polynomial function, any real number that I input will give me a real output. Moreover, it is a function that is already established. So each input has only one output. So that it is a function, and on top of it, every input will give you a real output, means my domain is all real numbers. Most often, this is the case for domain. Resist any temptation that you have to solve the equation. Do not set x squared minus 5 is equal to 0 and solve anything. The question is not asking you to find the zeros of the function. You're not solving for x-intercept. The question is a domain question, meaning what are all the possible input values to this function, or in other words, what are all the possible x values that can go into the function so that f of x, which is the output, is always a real number. And in this case, it is negative infinity to infinity. Now, when do you have to start worrying about domain restrictions? There are two scenarios that you will have to look at. In the first scenario, you want to make sure that division by 0 is not allowed. So whenever you have a potential for division by 0, you will have to restrict the domain. What is an example of that? So for example, if I give you a function like so. So this is a function, okay? So here you have a quotient. There is a denominator here which has a variable, right? So there is a potential for this denominator to become 0. Now, when the numerator becomes 0, that's okay. 0 divided by any number is still 0. But it is the denominator that you don't want to become 0. So 0 over 0 is a separate situation. We are here talking about any division by 0. So here, whenever your denominator becomes 0 or has the potential to become 0, those values have to be excluded, regardless of what the value of the numerator is. So I'm going to see what values of t will make my denominator 0. So how do I find that? In order to find that, I'm going to solve for this and see what values of t will make this denominator 0. Now t squared minus 4 is a difference of squares. This can be factored like so. So there are two factors. So that means when t is equal to positive 2 or negative 2, t squared minus 4 can become 0. So this tells me that I cannot allow the input to be either positive 2 or negative 2, because if I do that, my denominator will become 0. So I can write my domain in two ways. I can write it as all values of t such that t is not equal to 2 or negative 2. So these are the two restrictions on the domain. All other values are okay except 2 and negative 2. Now, if you're writing it in the interval notation, remember, -2 and 2 are not allowed in your domain, but everything else is. So all of these values can be written in an interval notation like so. All of these values can be written like so. All of these values can be written like so. So this is your domain. Your domain is from -∞ to -2, parentheses, because -2 itself is not allowed, then -2 to 2, and then 2 to infinity. Okay, so let's see one more example. In this example, we are going to look at the next restriction on a domain. If you have a radical with an even index, then you have to make sure that the radicand or the expression within the radical sign is always non-negative. Okay, so you want to make sure that the expression inside is non-negative. So another example, let's see. If you have g of x is equal to square root of 5 minus 5x. So you have an even radical because this is a square root. So I want the number. So when you substitute x for some value, the whatever number you have within the radical sign, it can be 0 or positive. It cannot be negative. So what I'm going to set it up as is, I don't want it to be negative, right? Non-negative, meaning 0 or more. So set it up like this. Then solve. So the 5 moves to the other side, becomes -5. Now I'll have to divide both sides by -5, and whenever you divide by a negative number, you have to flip the inequality symbol. So this becomes x is less than or equal to 1. So this is your domain is as an inequality, but how do you write it as an interval? So 1 is here, all values less than or equal to 1 is your domain. So your domain is going to be -∞ to 1. But here I use a bracket because 1 itself is okay, because when x is 1, the number within the radical is 0, and that's all right. It is a negative number that we don't want. So then you could have situations where these two are combined, right? So example is if I have something like h of z is equal to, let's say, 2z plus 3 over, let's say, z minus 4. So here you have a fraction, but you have a radical in the denominator, right? So whenever you see a radical, you know that you don't want it to be negative. However, this particular radical is in the denominator, meaning I don't want it to be 0 either. So the only difference in my setup would be I will just set it up as greater than 0 instead of greater than or equal to 0, because I don't want it to be 0 for the simple fact that it is in the denominator. Then you solve, you get this as the answer. So your domain will be 4 to infinity. Now let's look at this one more example. What if in the same setup as the previous problem, I just flip them like so? What if this was my expression, right? Then how will my answer be different? So now I have a radical in the numerator and I have a fraction also. So whenever I have a fraction, what was my rule? I didn't want the denominator to be 0. So I solve to find out what number will make my denominator 0, which is -3/2. So z cannot be -3/2. That is one restriction. What about the numerator? My numerator has a radical, which means it has to be non-negative. Because it is in the numerator, it can be 0. So I use the inequality greater than or equal to 0. And then I solve. This is what I have. So if I look at the domain of the final function, I had to incorporate both of these restrictions. What is the restriction from the first one? That -3/2 is not allowed. What is the restriction from the second one? It has to be greater than or equal to 4. You had to use the region of intersection. Now, this restriction of greater than or equal to 4 already excludes everything less than 4. And since -3/2 is in that side of it, we don't have to worry about it. So the final domain of this function will be 4 to infinity.